Hello everyone, welcome back to this NCRM workshop on text data analysis. This is part 2 of the sort of 3-part workshop we're doing today. In the second part, we're going to build upon what we looked at in the first part a moment ago, where we were looking at sort of a basic introduction to Python. And we're going to take what we learned there and we're going to use it to build a web scraper in order to scrape some very simple text data from a relatively simple website. Okay, and then in the third part of today, we'll go on to do some very basic analysis of that text data. Okay, so collecting textual data is perhaps one of the most difficult parts of any research project that uses textual data analysis. And this is despite the fact that there are numerous ways with which to gain access to such text data. So for example, you can find a data set that's already been created and analyzed by someone. So for example, in my personal research, I make all my data freely accessible via my GitHub page. So if you go on there, you'll find text data files you can download and use. You can use an API to access some text data. One example of this, for example, is the Python package tweepy, which enables you to easily build scrapers to scrape data from Twitter via the Twitter API. You can, if you're part of a higher education institution, quite often your university will have subscriptions to databases that contain various text data sets that you can download. Or finally, you can scrape your own data. And for the vast majority of your research projects, that's pretty much what you're going to want to do, right? Because your research project probably has a very specific focus, and the chances of the data set already existing that fulfill your needs are quite slim. So that's what we're going to focus on here today, is scraping our own data. In doing so, we're going to use two main modules. Hopefully you remember what modules are from part 1. We're going to use the request module, and we're going to use the HTML aspect of the XML package. Sorry, that's a bit of a mouthful. Okay, so what are these packages? Requests is essentially a package that enables the user to communicate with a website. Okay, it enables you to build your Python code, and using the request package, you can then get your Python code to simulate a person using a web browser to visit a website. That's essentially all the request package is. The HTML aspect of the LXML package then is just a way to take what the computer gets from the web page and convert it into a text that we can actually work with as humans and data analysts. Okay, and you'll see what that means a little bit more as we sort of go through this second session. Okay, so the first thing we want to do is get a website. And so for this exercise, we are going to scrape the University of Exeter's sociology staff list page, okay? And there's absolutely no specific reason as to why I chose this particular page at all, okay? And we're going to sort of get this information, which is all freely available on the internet anyway. And we're going to do some simple text data analysis on the job descriptions that people have for the various roles. So we start off by getting our URL, which we've done here. We just take this and we create a new variable called URL, and this variable is a string variable and it's just our URL. We then create a new variable called page, and page involves calling the requests module that we've already imported, and then from request we use the .get function and then feed in our URL. So this just says, right Python, I want you to use the requests package And from that, I want you to use the get function, and I'll basically want you to go and get the data, the HTML code that's contained at this URL. Run that. Okay. And we can test whether or not it works by typing the word, by using the page.content function. Note here that the HTML for an entire web page is incredibly long. So all I'm saying, so I'm just using an index here just to say, just give me the first 300 characters just so we can see that it's actually grabbed something. And you can see here, it has. Okay. Equally, if you were to remove that, you get the entirety of the HTML page, but that'd be really long for the screen, so we're not going to bother looking at the whole thing. Right now, we just want to make sure it's grabbed something. Okay. So we now have this raw HTML code, okay, which we've collected from the URL using the request package, okay. We now need to sort of be able to handle this code in a way that enables us to A, make sense of it, and B, extract the data that we want. And to do that, we're going to use this LXML package in order to sorry, I do apologize. Sorry for that, I do apologize. I said the word package and set off my Alexa. What was I? Yes. So the LXML package then enables us to get this raw HTML code and sort of build what we call a tree. Okay? And what this essentially does is that it simulates a user going to a web page and clicking on a link like this. It simulates that behavior. Okay. I apologize for my star photo image. Okay, so it simulates that behavior. Okay, and so to actually do this, we create a new variable called tree, and we call our HTML from the package we imported, and we say from string page.content. So what this does here, it takes this page.content, which if you remember, generates all the HTML from this page, and that's saved as one single string. Okay, so just as this is a string here, all of our HTML code is saved as a single string, just like that. This command then takes such a string and it converts it into the sort of hierarchical sort of tree structure. Okay, and if we were to print that out, you see it says print element HTML at blah blah blah. Okay, so what it's done there is that it hasn't printed out the HTML or a sort of representation of this tree. Instead, it's created an element that internally it knows it's HTML code in a tree, but it's made the judgment call that we don't want to see that, and it just tells us that instead this is a HTML element, which is useful. That's all we need to know as users for the time being. Now, there are a bunch of different ways to access different elements of this tree. And it's also important to note that this tree contains the entirety of the layout of the page, right? So all of this stuff here, all these little pop-ups and everything, all of this here, it contains all of that. But we obviously don't want all of that, okay? We only want to access specific parts. Specifically here, we're only interested in the user profiles going down here, okay? So we need to find a way to isolate these particular tree branches from the overall tree. And the way we're going to do that in today's session is using these things called XPaths. Now, what are XPaths? We're going to spend some time here looking at XPaths because they're a little bit tricky, but they're worth understanding because once you understand how they work, it makes extracting data from a website incredibly easy. Okay, so essentially, yeah, XPaths are a way of navigating this tree structure that we've built. And you can think of it as each sort of sub-branch on the tree having its own specific address, and that XPaths are a way to, they're essentially an address to get to that part of the tree. Okay, sorry, metaphors are not my forte. Okay, so as an example, let's say that on our web page here, let's say we wanted to look at the research section. And so let's say, yeah, we want to get the research section of this, okay? We can get the XPath, okay? So if you look at this line here, okay, we were to run that, okay, we see that has grabbed our research section here, okay? And this is the XPath to get to there, okay? Now at this point, you're perhaps asking yourself, well, that's very well and good, but how do we get this rather complicated looking piece of code, if you will? Well, with most web browsers, I'm using Chrome here. Firefox has a similar feature. It's actually really easy. So you right click on your web page, go down to inspect, and it pulls up this, which is all the HTML for this page, right? You then go to the element you're interested in, click right click, click inspect, and it takes you to that corresponding part, which will be highlighted as it is here, okay? You then right click on that and say copy, and then XPath. That will then give you an XPath, which you can feed into your string variable, just like I've done here. And it will give you that, okay? Now, you might notice there's a little bit difference between what I've just typed in there and what I typed in here. That's because I just added a /text parentheses onto the end, okay? And that is just me saying I want to get the text from this section, okay? So instead of just giving me the HTML element, which just feeding you a normal XPath will, by putting /text parentheses, I get the actual text that's said, which is our research, okay? And for all the XPaths you see as we go on, that's all we're going to do. That's exactly how you get the XPath, okay? So let's say we wanted to get the XPath for a specific staff member's profile, okay? We go down to here, again, right click, inspect, it takes me to that location there, and I right click on it again, on the highlighted bit again, and click copy, XPaths, and that gives me the XPath here, right? Okay, and if I print that out, I get told that it's an HTML element, and again, if I put /text speech marks, I get the text, which is my name, because it's my profile and I have that much of an ego. I'm running this on my own name. Okay, so what if we then wanted to get the URL of my staff page? Okay, so some of you might have noticed that when you click on a user profile, it goes to a separate page which has a slightly different URL, right? As staff forward, the landing page is sociology /staff /, and then the website is made up, but it uses our surnames then to take us to the page that contains our specific profile. Okay, this is relatively simple here, but some websites have more complicated URL structure. Okay, but what if we wanted to get the URL of that? Well, just as we typed up here, just as we put after the XPath, we put text parentheses in order to get the text that said, if we put the @href, which stands for hyperlink reference, we get the reference for it, okay? We can then combine this with our URL variable from up here, right? We can then just say, ask Python to print out our URL variable plus this command here, right? And because you can add strings together, the output is our full URL. And because Jupyter Notebooks, which we're working on here, are interactive, it means I can actually just click on that and it takes me straight to the page. So there are some other XPath expressions which are quite useful. Okay, so we've seen text and href. There are some others that are quite useful. So the contains function enables you to get the XPaths of various elements that contain specific text. So let's say, for example, I wanted to look up, find any text that contain the name Chris. Okay, so I create a new variable called Chris, and then I'll say equals tree XPath, and then contains Chris. And this looks for any A tag that contains the word Chris. What do I mean by A tags? Well, like I said, if you look at a specific profile, you'll see that the individual profile's name, you'll see the href, which we called a moment ago, the text, which is the name, and you see these are all included with an A either side of it. Okay, and that's just because you can think of this element simply as being an A element. Okay, so all this code here is saying, right, is that these two forward slashes say, skip all of this stuff above here. Okay, it simulates you typing all of that out for you, and it says, get me any of these A elements, okay, these A elements that contain the word Chris, and it does that. And when I then ask it to print this out for me, and it tells me that there are 4 A tags with Chris. Okay. If I also ask it just to print out Chris, you'll see we get the 4 separate elements. Okay. And if I did the text, oh, it's not text, is it? It's text contains and content, and I've got that written down there anyway. So yeah, if we just print out the Chris, you see we've got the 4 separate elements. Okay. And if we, oh, that can't be done on a list. And if let's say we wanted to look at the actual name of the first Chris in our list, we type this command, which says, Chris 0. So as we saw, if we print this, you see we get a Python list where each element in the list is a specific HTML element. Okay, and this here, length 4, it tells us there's 4 elements in this list, which we can see there. So down here, I say get the first element and get the text from it. And we can see that the first element is for Christine, member of our department. The second element is my colleague Chris Playford, and so on and so forth. Okay, and we've got a Christopher there. So you can see it hasn't just found a specific match to just Chris, but any word that starts with any name that begins with a capital C and then contains HRIS. Okay. There are some path operators, and these work exactly the same way as the arithmetic operators do in Python that we looked at during the first section. And they enable us to do certain things. So, for example, if we said we got fed up of me looking at my own profile, and we said we wanted to select all the links that do not have my name, Lewis, in the text, we can do something similar to this. Okay, so let's run this, see what we get. So I've asked it to get me all of these A tags. Okay, and remember, each of these A tags corresponds to a specific user profile. Okay, so basically by saying how many get me the length of the list of A tags here, I'm essentially asking how many profiles are there on the page, and my printout tells me that there's 167. Okay, I then say that I want to get all of the A tags again, but the ones that do not contain my name. Okay, and I save that as a variable called noLewis. And if I ask it to print me noLewis, you can see the output is 166 profiles, because it's removed one profile, specifically mine, because it contains the word Lewis. And because no one else spells Lewis in this weird way, it's obviously just my profile that's been removed. If I wanted to be more specific in here, I could put Lewis Brace, and we, still get the same result, but it will just be more specific to me. Okay. Likewise, let's say we wanted to get all of the Chris's. If you remember, we had 4 hits for names that contained the letters C, capital C, H, R, I, S. Let's say we wanted to get all of those, but we wanted to remove my colleague Chris Playford. We can use the same command as we used above to get all the Chris's, namely this bit here, and we can say and not contains Playford. So all we're saying here is do the match exactly like you did before, but exclude any of the profiles that also contain the string Playford. And if we run that, you can see we get 3, which makes sense. So we have 4 hits, we remove 1, we have 3. And there are some other LXML methods we can use in addition to XPath stuff in order to access data from the HTML method, okay, from the HTML object. We've already seen the text content method, that's what we used up there. One aspect of the HTML package we can use is a different way to select objects. We can do that by selecting what we call the Cascading style sheet names. Okay, and that's basically involves having a bit more of a knowledge of how the HTML works. And so if you look down here, we'll find in the a div class section called main menu. If you scroll down through the collection here, eventually you'll find what we call a div object. A div object is exactly the same as the in theory, it's exactly the same as the A elements we were looking at a moment ago, which is a different type of elements. And you'll find one called main menu. Okay, and then we use the HTML method .getText to get all the content from the main menu. And you can see what it's done is get all of the text from this specific object here. And again, I could find that by using right-click and inspect. If I open that up, you'll find all the details, all the information you need down here. Okay. There's also the find class function, which basically enables me to select the profile list, which is a different way again. So again, as you scroll down here, you'll find elements called profile lists. And and whereas this section up here is titled main menu in the CSS selector, further on down, the profile names are saved as profile lists. Okay, and we print out the p list there, and we see the HTML elements. And then I use the here I just use the text content function again in order to get the text for the first entry, the first element in this list, which is the content for our head of department, Mike Michaels, who is obviously at the top of the list because he's the head of department. You also get elements by ID, which is just, again, another way of using a different part of the tag to select the part of the HTML code you want, okay? And the main reason for going through these different bits here is just to get you to realize that each tag has different ways of accessing it. Okay, you can access it via the file path, via the tag name, via the tag type, and so on. There's different ways to access the exact same part of the HTML tree we've created. And I suggest that's all we're going to cover in terms of XPaths and CSS today. If you start to do a lot of web scraping, or you start to build other scrapers, I suggest you spend some time learning about XPaths and CSS. There's a lot of useful resources online. You literally just type in XPath into Google or CSS into Google, and you'll find tutorials that will help you understand it. Looking at those tutorials and also having a web page open and looking at examples of HTML code like this means practice with it a little bit and you'll pick it up in no time. Okay? It looks really complicated at first, but the more you practice, the easier it becomes. Much like learning a natural human language. Okay, with that covered, let's now take a look at building our first website scraper. Okay. As I said before, we're going to scrape the staff profiles of the University of Exeter's SPA page, that Sociology, Philosophy and Anthropology page. Okay. And we're going to do this in 2 steps. Okay. First, we're going to get the links to each of the staff members' profiles, and then we're going to extract the profile content. Okay. So if you were a user, this is going to be equivalent to you going to the page, clicking on the profile, getting the data, going to the next profile, getting the data, and so on and so forth for all of the 167 profiles we have on here. Okay. Obviously, as a human being, you don't want to do that. It takes too much effort. So we're going to build a web scraper to do it for us. Okay. Now, we've already created our tree, which we did up here before we started looking at XPaths, and we can still access that. So all we do here is again use some CSS, right? We're saying, look, okay, this is across. What we've got here is a bit of code we use with XPaths and sort of CSS inside. So we're saying we're going to create a new variable called table, and that table is going to be equal to getting the XPaths from our tree element, where all the XPaths, we're going to get the XPaths for each of the tags that has a class object that equals profile list. Okay, so that involves just going to the page here, and if we're to navigate down, you see we've got our tags here, right? So we've got academic staff here, and you can see here that we have classes and they're called profile lists. And if we click on that, contained within here, oh, sorry, wrong one, we have each of our individual profiles. And you can see the corresponding profile bar being highlighted on the left-hand side as I scroll down. Okay, so these are all, each of these A tags that correspond to our profiles are saved under this class object called list, profile lists. Okay, and like I said before, these 2 forward slashes and the star just says, simulate all of this stuff above that. Okay, so it's saying get each of these for us. Okay, that's all that line does. And if we run that, we then ask it to tell us the length of the table, and it says 127. And if we ask it to print the first element of that, it gives us tells us it's an HTML element. Okay. Now, if you look closely at these, right, you'll see that each of the elements in our profile list contains this annoying header, right? Academic staff. Okay. We want to get rid of that. Okay. We don't want that in our analysis at all. Okay. And these will be sprinkled throughout, so these headers are sprinkled throughout our content, throughout our page. You see we've got the head of department here, the academic staff one here, and then the others all have the same. So we're going to need to deal with this issue, okay? And also, you'll notice that the information we want is actually contained within a tag, and that the header rows don't have these tags, okay? So that's all. So how we deal with that is by using this. We say, in table, we find all that begins with TD, okay? And if we print this out, and the way we get rid of these, right? So if we select our table, we select the first element here, and we print this out, we see that our header contains none of these TD tags, okay? So if you look at these don't contain any TDs, okay? But if you scroll down to here, in TR, you'll see that the actual user profiles do have the TD tags. Again, these are just like the A element tags, but just a different type of them. You don't need to worry about the difference between them at this moment in time, Okay. The main thing to take away here is that each of the actual bits of information we want has a TD tag. These annoying headers that we don't want don't have a TD tag; they have a TH tag instead. So if we run this, find all, and the find all element is just a function in the request package that says find all of the HTML elements that fulfill this criteria. It acts much like a conditional, like we saw in part 1, right? And we say find all of the tags that contain this TD element. And if I print that out, you see it prints a list here that has no objects in it because there are no TD elements in these annoying header bits. Okay. But if we say look at the non-headers, okay, and find the TD, you'll find it will print stuff out. Okay, and that's this print statement here, which gives us 3 HTML objects. That's because in the non-header section, like I said here, look, we do have the TD objects, and you see we have 3 of them. Okay, the first one corresponds to the profile name. The second one is that sort of detail, is the profile user details, and the third one is our building name on campus. And so in these print statements here, then I just say from my non-header variable, get me the text content of the first and the second bit, and you can see we get the corresponding, we get the name and the sort of bio, if you will, of the individual concerned. Okay. Now, this above code, the purpose of this was to do 2 things. One, to show you sort of that you have to be wary of how some websites are structured. Otherwise, you could end up including bits of text into your data set you don't want. But it was also to showcase this useful find all method, which is basically a way of finding an XPath within another XPath. Now, we're nearly close to sort of actually building our scraper to extract our content. The last thing we need to do is get the profile link for each of the individual profiles. And again, if you were to look at each of the staff pages, you'll see that as you scroll down, if you look for the TD element that contains the profile's name, and if you were to expand that, you'll find the href, i.e. that's the URL for that specific profile is contained within this username function. Okay, sorry, this profile name function. Okay, which means so we can access that, right? We just call the specific HTML object we want. We say find the A tag, the A element, yeah, the A tag which is there, and from that extract the href attribute. So our code goes to the it goes to the A tag, finds the href attribute and gives it back to us. Okay, and if we were to print that out, you see it gives us the Michael, which is the surname, which is the specific URL for that part of the profile. Okay. Now, we pretty much have everything we need. The only thing we need to do now is build a for loop like the kind we saw in part 1 in order to loop through each of the profiles on this page and collect the data that we want. So that's what this bit of code here does. Okay. So first we create a table object, which is us collecting, if you remember, collecting the using the request package to go to a URL and collect all the HTML data and then convert it into this tree. And we say we get the main content, so that's pretty much everything on this page. We then create a blank list. Remember list from the first one, from the first video, right? That can store all types of content. We create a blank list, and if you remember, lists act like data containers. So we're creating this blank list with the intention that we're just going to put our user profiles into this container to store them there. Okay. We know that each of the profiles is saved as a specific row in our table object. So we say for row in table, i.e. for each profile on the page, do a thing. Okay. this for loop works exactly the same way as our species list for loop in the first video works, okay? And that's just iterating through each element in the sequence. But instead of just printing out that element to the screen like we did in the first video, we're going to be a little bit more complicated. We're saying from each of these elements in this list, create an object called cell, where the cells contain all these TD objects, i.e., if you remember, ignore the headers, which don't contain TD, but get the parts of the staff profile that do contain TD, i.e., the profile name, the bio, and the building location. Yeah. And if it doesn't equal 0, this is a conditional I've had to put in because some staff members don't have any information on their profile pages, which could cause an error when scraping. So I just say, if they don't have any content, ignore them. If they do, add them to the list, okay? Because we don't want, A, the scraper won't work if we don't put this conditional in. B, it's not really useful to our analysis if they don't have any data anyway, okay? We then say, okay, this next bit of the code then says our page URL is going to be the current cell is going to be the first element of our cells list that has an A tag, okay? So the cells, if you remember, contain 3 HTML elements, which correspond to these 1, 2, 3 parts of the page. And we're saying we're going to go to the first element, which is the name, which, if you remember, contains the href object, which is the URL part of the profile, and we're going to extract that, okay? And again, some profiles don't have a one of the profiles on this page doesn't actually have a hyperlink to a user profile for some admin reason that I'm unaware of. So I just say, if this object actually exists, do this. If not, ignore it. Okay, and that's all this says, okay? In Python and requests package terminology, if we ask to get an element like this that doesn't exist, then it's saved as what we call a none type object. So for that one specific profile, it doesn't obviously have an A tag because it doesn't have a proper name associated with it and a href object associated with it. That will be saved as a none type object, okay? And so that just says, if this object is none, ignore it, okay? If, however, it does contain an A type object, which the vast majority of the profiles do, as we can see here, find the href object from that A tag, i.e., go to the first TD, go to the A tag and grab that href, okay, object, and then save the content for each of these 3 sections to a dictionary, okay? So we save name, and remember dictionaries from the first video, okay, where we have key value pairs. Keys are the things you want to look up. The values are the definitions, if you're thinking of the analogy to the natural language dictionary. So we say first key is name, and that's going to be the name of the profile. Okay, so the value is going to be the text. So in this case, Professor Mike Michaels, Dr. Alexei, so on. The second element in the dictionary is going to be the page URL. So it's going to be, this bit here, Michael. The third one's going to be position, okay? And so that corresponds to the job title here, okay? We're basically going to say this all as the position, okay? That's just what we're going to call it from now on. And that's what this bit of code here extracts, okay? We run that. And then we just print out this line here, which just tells us that this operation worked successfully and it successfully extracted information for 118 members of staff. And then we can just ask to explore one of them at random. So if we ask to look at profile number 12 on the list, we get all the details for Professor John Dupree. What am I? 0, 1, 2, 3. Okay, so if we be just for a look at mine, just because I'm not sure how much my colleagues will appreciate us talking about them in depth. And also because because I'm lazy, I've got a lot less information on my page than others. Don't tell HR about me. So you can see here we've got a dictionary that contains 3 key value pairs. Okay, like I said, we've got name, which contains the text of a name, which corresponds to that on the website, Dr. Lewis Grace. PageUrl, if we were to, let's minimize this a bit, and we go down to the profile list here, and we find the profile link to me. Here we go. Oh, wrong one. And then we go into the TD object here and the href here. We see we've got our URL, and that matches to that. And then position is lecture and data analysis, which you can see is clearly pulled from there. Okay. So for our second step, okay, we now want to go to each of these profiles, okay, and actually extract the content from them. Okay. And we're essentially going to do this, like I said a moment ago, by going to the page and looping through each of the profiles in turn. So we start off by going to the page in the usual way. And you can see here, I'll just print out my usual thing to tell me that it successfully extracted all the information from this specific page. And here I've asked it, just as a test, just to teach you guys, I've asked it to extract all the content from Mike's page here. Now, after looking at the page, if we were to go and look at the HTML for this page, right, we would find all the text and stuff we want is contained within these p tags, right? They're all saved in these little p tags. Okay. And so we can actually use these to extract the content that we want. And so, for example, if we wanted to get all of the overview text, i.e. all of the text contained within here, even though it's in multiple paragraphs, we can just ask it to go to the we can use the CSS selector to find the part that has the ID equals overview and select all of the p tags from that. And if we were to run that and then print out, you see it's extracted the text from there. Okay, and we can use this to extract pull other aspects of the Mike's page. Okay, so instead of just looking at the overview, if we wanted to look at the research section, okay, you'll see this corresponds to the research, so on. Or we can grab everything at once. So here I've just gone, this code essentially says go to this page here and just extract all of the text, because all of the text we know is saved in these little p tags. So just extract it all. If we do that and print that out, you see we get everything we need. Okay, so we have telephone number, office name, so on, even right down to the copyright text that we see at the bottom of the university page. Okay. So in building this first scraper of ours, we're going to keep things simple, and we're going to use all of the available page content moving forward. Now we start to enter one of the last stages of what we're going to do today. Okay, and that is we're going to do all of the above, but for every single profile on the page. Okay, and we just do this in a very simple way by putting it into a for loop. Okay, and you can see all this is what we've done above, but because it's in a for loop, we're going to do it for each of the staff profiles in our staff profiles list, which, if you remember, is the list we created above where we saved all of these staff profile information. And if we run that, in Jupyter Notebooks, when the circle here is fully black or grey, depending on the contrast of your screen, it means Python's currently thinking and currently operating. Okay, so we can see it's currently going through and collecting all this profile information. So we're just going to have to wait for that to run for a second. So I'm just going to pause the video while that's running, because it's going to take a couple of minutes. You won't notice the difference because I'm just going to pause it and unpause the recording again. Okay, so that code ran and it collected all the details. Okay, just as an example, we select a random profile. I've decided to look at profile number 11 on the page and just grab all the content for that. You can see we have all the information there. I just believe that was number 3, so if I run that, I've got all my details there, including my interests and what I teach and so on. Okay. Now let's say as an example, we just wanted to look up the number of staff on the SPA page that say that they work with quantitative analysis or statistical analysis, for example. We can build a very, very basic search, and that's what we do here, look, right? So I create a new list called quantitative, which is empty, just like our staff profile list was at the start. Okay, I then say for each of the row in our staff profiles, which we've gone through a moment ago, if the page content in the row contains either the word quant or statistic, add that to this list. Okay, so it goes through this page content for each member of staff on their staff page, and if it contains the word quant or statistics, it adds it to this list here. Okay, it adds it to this list. I then just ask Python to print out that list, and it tells me it's found 8 members of staff that have the word quant or statistic on their profile page. You'll notice mine hasn't come up, and that's because if you look at my page content, I have quantitative, not quant. And that's to do with what I mentioned in the first video, where in this specific case, Python's looked for an exact match, i.e. so it's looked for quant, not quantitative, okay? But it's found 8 members of staff that have either of these 2 words in their name, okay? So that's just a quick way that you can sort of search data if you wanted to explore it. But now that we've got our data, okay, we've got all our staff profiles, we now want to save this text data to a file, okay? And then that gives us some text data we can then do some analysis with. To save it to a file, we import this package called JSON, because we're going to save it as a JSON file. And a JSON file is just a way of saving hierarchical data, okay? So all this is going to do is save each of the dictionaries. If you remember, each profile on this page has been saved as its own independent dictionary. It's going to take each of those dictionaries and put them into a list and save that as a text file, okay? And so I import the JSON package, and then I just use the with open, which is a way of saving a file path, save as J file, okay? All this open function takes 2 arguments. The first argument is the file location and the file name, okay? So I say I want it to save my the file I'm about to create to this location, and I want it to save it as profiles.json. And I'm opening it with W, okay, because I want to write to the file, okay? And I'm going to save it as a J file, short for JSON file. I'll leave a link in the literature so you can look up the various references for these. But basically saying here, I want you to save my staff profiles information as a J file with a 4-point index. So it's 4 white space characters in, just so I can view it easily and separate things with a comma. Okay. And then this line here just says I want you to separate each of the elements. So each of the dictionaries in my list, I want to be separated with a blank line, i.e. save them to a new line. And when you run that line, you'll get a file that looks something like this. You'll see my profiles list has been generated where I wanted it to. And if I were to open that up, you'll see that each of my dictionaries that correspond to a user profile has been saved, separated by a comma and a space as I asked it to. Okay, so that concludes this second part of this workshop. We've got one more part to go, and in that next part, we are actually going to start doing some very, very basic text analysis, just so you can get a grip with some of the basics of it. Okay, I shall see you in the next video.